Welcome all to AISSMS Institute of Information Technology Pune. In this video, we are going to study indeterminate forms and how to solve the limit which tends to indeterminate forms. We will see that we will use L'Hospital's rule for finding the limits which is of the indeterminate forms. So what are the indeterminate forms? In general, if we have the limit of the form f of x upon g of x when x tends to a, then this limit is equal to the limit of the numerator divided by the limit of the denominator. So we can find this limit by taking separate limit of the numerator and the denominator. But what will happen if both the limits are going to be 0? So we will get a division form of 0 by 0. We know that 0 by 0 is not determined, so this becomes meaningless. So this form becomes meaningless. So such a case is known as the indeterminate forms. Such a case is known as indeterminate form. There are total 7 indeterminate forms including 0 by 0. So this is one form. The second form is infinity by infinity. The third form is 0 into infinity. The fourth form is infinity minus infinity, 0 raised to 0, 1 raised to infinity, and infinity raised to 0. All these are known as the indeterminate forms, means the value of this cannot be determined. Now such limits can be evaluated with the help of L'Hospital's rule. So L'Hospital was a mathematician who gave this rule, and we will use his rule to determine such limits. So what is L'Hospital rule? So we will define the L'Hospital rule by 0 by 0 form. We will later see that all these indeterminate form can be converted to 0 by 0 form. So we will first study that what is the L'Hospital's rule for 0 by 0 form. If f of x and g of x are two functions such that they satisfy the following three properties. The first property is that limit of f of x as x tends to a is same as the limit of g of x as x tends to a, which is 0. Means both the limit should go to 0 individually. The second condition is that f dash of x and g of x both should exist, but also g dash of x should not be equal to 0. The third condition is that limit x tends to a, f dash of x divided by g dash of x exist. Then we can say that the limit as x tends to a of f of x upon g of x is equals to limit x tends to a, f dash of x upon g dash of x. So by using this L'Hospital's rule, we will solve certain examples of the limits which are of the indeterminate forms. We will consider an example where we will use the L'Hospital's rule. So consider this example. We have, so evaluate limit as x tends to 0, x minus tan x divided by x cube, x minus tan x divided by x cube. Here we can observe that, so let x minus tan x divided by x cube, this is same as f of x divided by g of x, where you can take f of x as x minus tan x and g of x as x cube. We can observe that limit of f of x as x tends to 0 is limit of x minus tan x as x tends to 0. So this is nothing but 0 minus 0. So that will be 0. We know that tan 0 is 0. So this limit tends to 0. Also, limit x tends to 0 of g of x is equals to limit x tends to 0 of x cube. This is also 0. Hence, this is of the 0 by 0 form. Hence, this limit is of the 0 by 0 form. Therefore, limit x tends to 0 f of x upon g of x is of 0 by 0 form. Now this limit is of the 0 by 0 form, so that L'Hospital's rule is applicable. So that L'Hospital's rule is applicable. Now if L'Hospital's rule is applicable, then limit x tends to 0 f of x upon g of x is equals to limit x tends to 0 f dash of x divided by g dash of x. Means we have to find the derivative of f and the derivative of g separately and substitute there. Therefore limit as x tends to 0 of x minus tan x divided by x cube. This is same as limit. So what is the derivative of numerator? What is derivative of x? Derivative of x is 1 minus what is derivative of tan x? Derivative of tan x is sec square x divided by what is derivative of x cube? Derivative of x cube is 3x square. So we have found the derivative of numerator and denominator separately. So this is equals to limit as x tends to 0. Now 1 minus sec square x is tan square x divided by 3x square. Now this can be evaluated and we can take 1 by 3 as outside the limit because it is a constant. Now this is limit x tends to 0 of tan x divided by x its square. Now we know that limit x tends to 0 of tan x upon x is equals to 1. So this is equals to this limit x tends to 0 x minus tan x divided by x cube, this will be equal to 1 by 3. So this is the answer. This is the final answer. We are getting the value of the limit as 1 by 3.